Let's have a look at how ServiceOps, connected digital experiences with AI, helps bridge the gap between operations management and service management to help you work smarter and resolve issues quickly. I'll run through a typical scenario on how AI/ML is used in service management to correlate incidents for users experiencing poor performance for a retail outlet service with real-time insights from operations management to triage and remediate. It all starts in the Helix ITSM Insights workspace. This is used to track incidents in real time and generate clusters you can use to prioritize and respond to trending issues. It also reduces service desk burden through ticket matching and incident consolidation. As you can see, 55 new incidents over the last 5 hours have been grouped and rolled up into the user report slowness incident cluster for retail outlet. This cluster has also been flagged as a possible major incident by the system. Helix uses a combination of BERT AI, NLP, and GPT models to analyze and group incidents and generate meaningful names for clusters. These are all the incidents grouped by AI. They describe the same issue, a general slowdown using the application. They all also originate from the Americas. A recommended parent has been identified we can use to quickly consolidate other incidents, so the service desk only needs to manage one rather than 55. Drilling into the incident, we can see a probable root cause has been identified to inform the service desk as they work the case and provide more context. This information is surfaced real-time from operations management and reduces the need for agents to consult other systems or personnel to find out what's going on or the current status of the service. Currently, it's indicating a 70% probability the root cause is a network device. Let's drill down further. Drilling down takes us to the live operations management workspace for the affected retail outlet service. There's a lot of useful information here to triage the issue. The service is in a critical state. The state hasn't changed for 3 hours. It has a relatively low health score of 10. Of the 31 events that have hit the model, 31 have deemed to be impacting. And on the service health timeline, there is a change that occurred 30 minutes before the issue was reported, which will be of interest. Being designed with open observability in mind, operations management is able to ingest events, metrics, and importantly topology from other tools to support end-to-end service-centric AIOps monitoring from a single pane of glass. Dynatrace, AppD, New Relic, Splunk, Nagios, and other tools are all supported. Zooming in takes us to a filtered view of just the affected service chain and causal and affected CIs. Clearly there's still an issue here as the KPIs used to track the health of the service are impacted with one critically. Health KPIs can be any metric like an end-user response time, a jitter measurement. It could also be a business metric like an order or a transaction volume. Both of these are end-user response time metrics from different locations, India and Texas, with the Texas measurement in a critical alarm because it has exceeded the threshold at 2.6 seconds. India is currently unaffected at 1.2 seconds. There's also a proactive prediction provided, which forecasts these out into the future. And as we can see, it's predicting that the India site will also suffer a response time degradation if we don't address this issue. So let's have a look at the cause in more detail. The problematic network device was identified from a log event for a network switch and interface with a weighting of 27. Switching to changes and having a look at the changes, we can see that the change that was originally on the timeline above actually directly impacts the problematic device, and it's still in an implementation process. So that's something to look at, and its impact score has been adjusted accordingly. We now have 2 very good indicators pointing to the potential root cause. Let's have a look at other events affecting the service. Situations are event clusters affecting the service and are created using similar AI/ML algorithms used for incidents. Events are analyzed according to time and topology as well as message, and they are grouped and noise reduced before AI reasoning is used to rank and identify root causes. And this is all made possible because we understand the topology. Drilling down, we provided with a similar view of the causal service path. We can see an incident has already been created and for the retail outlet service rather than for individual events. The GPT generated human readable summary up top tells us a downed interface is impacting the response time. The situation also shows other ranked events for consideration as well. And as we can see here, it's all related to the network device itself and with other related issues. We could also see this situation has occurred 23 times in the past. With the incident assigned to the correct team, an L2 network engineer would usually take over and triage and remediate the issue from this point. To understand how situations get evaluated using models, let's switch to the root cause view. This shows us all of the events that were evaluated. On the top is the root cause event impacting the switch, which we drill into. We can see the event and we can drill down and we can get details of that. Critical P1, repeated multiple times. Down the bottom, we can see the events that impact the business service. We drill down, we see United States, Texas, and we see metrics from App Dynamic End User Experience Monitoring. This is the causality chain that led up to the impact and is what we store as a fingerprint in our knowledge graph should this happen again to inform decisions and specifically the recommendations we make for automation. So at this point, the network engineer is likely convinced it's a network issue, so what can they do about it? In this case, the system is recommending 3 automations based on the previous success or failure. These can be broken across your orchestration estate, either manually or automatically, to remediate the situation. However, before running or choosing to run the automation, they can also go back in time and review some of the similar situations to see what actually was run and was successful. In this case, drilling down, and we can see the reset VLAN configuration was successful and the other options failed. It's pretty obvious that this is going to be the right automation to fix the issue. We can now go in and execute the automation and have that run and brokered. Once it's triggered, in this instance, you can see it's initiated a change process to put more control around the VLAN configuration reset. If it was a low-risk automation or an automation just to triage and capture more data, you could just let it execute. Okay, so summarize what we covered in the ServiceOps use case. We started in ITSM insights and real-time incident correlation to group trending incidents into clusters using AI ML. We saw how incidents can be consolidated to reduce service desk fatigue. We saw service status and probable cause information surface from operations management to inform service desk decisions, and we drilled down into operations management to investigate and triage the root cause. We also saw how noise reduction and AI/ML is applied to cluster events for services and identify root causes. Lastly, we triggered a recommended automation to resolve this issue.